Tonight's lesson is going to be on fraction vocabulary. It's not found directly in our textbook, so we're just reviewing things that we've learned in other years that will be helpful for us as we continue on. Our goal today is going to be to find equivalent fractions, simplify fractions, and convert between improper fractions and mixed numbers. We're going to start by reviewing equivalent fractions, which are fractions that have different numerators and denominators but have the same value. We find them by multiplying or dividing both the numerator and the denominator by the same number. So we'll start out by reminding ourselves that the numerator is the number found on the top of a fraction. So in the first fraction 1/5, it would be the 1. This would be our numerator. And our denominator is going to be the number on the bottom. You can think of the word down starts with D, and so does denominator, so that might help us remember. So we can find an equivalent fraction to 1/5 by multiplying or dividing each number by the same number. Well, when I look at 1/5, the number 1 can only be divided by itself, by the number 1, and that's not going to do anything or change it. So I'm not going to be able to use division in this sense, but I'm going to be able to use multiplication. So let's say I multiplied 1/5, and I took the numerator and denominator and multiplied each by 2. The resulting fraction would look like 2 over 10. So 2/10 would be an equivalent fraction to 1/5. I also could take the fraction 1/5 and I could multiply the top and the bottom by 8. Multiplying the numerator by 8 gives me 8 as my resulting numerator and 40 on my denominator. So 8/40 is both equal to 2/10 and it's also equal to 1/5. So there's an infinite number of equivalent fractions that I could come to for each fraction that I start with. The number 6/8 gives me a couple of options. I notice immediately that 6 and 8 are both even numbers, so I know I could divide them each by 2. So this time I can use division as a method for me. If I divide 6 by 2, I'm going to get 3. If I divide 8 by 2, I'm going to get 4, so 3/4 is equivalent to 6/8. I could also use multiplication though in this sense. Notice 3/4, there's no number that's going to divide evenly into both of them. The only thing I can divide into the numerator is 3, and 3 doesn't go evenly into 4. So I can't go any lower there, but 6/8 I could change by multiplying it by something. So let's say I multiply the top and the bottom by 3. 6 times 3 is going to be 18, and 8 times 3 is going to be 24. So 24 is going to be equivalent to both 6/8 and to 3/4. Again, I could go on and on and on, but this is the basic idea of what equivalent fractions mean. When I simplify fractions, I'm looking at a similar method to finding equivalent fractions. Another way of saying this is reducing fractions, and this simply means to divide the numerator and the denominator by the same number until there are no other numbers that go in evenly besides 1. So in simplifying, I'm always using division, and I'm only using division. So when I look at 20 divided by 2, I notice right away that I could divide both by 2. If I divide 20 by 2, I'm going to get 10. And if I divide 42 by 2, I'm going to get 21. Now here's where those divisibility rules are again going to be helpful to us. I need to look at my numbers 10 and 21 and decide whether or not there's another number that goes evenly into each. I usually start and look at one of the numbers, typically the smaller number. So I'm going to look at the number 10, and I'm going to say, well, what are the factors of 10? You don't actually have to write these down. I'm just going to write them down here to show you what I'm talking about. But the only things that go into 10 are going to be, well, 1. But I know that when I divide something by 1, it's not going to change anything. So I do have 2 and 5, and I also have 10. Those are going to be the only 3 numbers that divide into 10. Well, 2 does not go into 21. It's not an even number, so I won't be able to use that here. 5 also does not go into 21. It doesn't end in a 0 or a 5, and 10 does not go into 21 evenly. It only ends in a 0. So I know there's no other numbers that go evenly into both. So 10 over 21 is my fraction 20 over 42 in reduced or simplified form. Taking a look at 21 over 57, again, this is where it's really important I know those divisibility rules. When I look at 21, I know that 3 and 7 are factors. I know that 21 is a factor, and 1, although 1 won't help me out. So then if I'm kind of creating my t-chart in my head, 4 doesn't go in evenly, neither does 5, neither does 6, so those are my only 3 options. When I look at 57, I know that the sum of those digits is 12, so I know 3 is going to go in, so that tells me that I should try dividing the top and the bottom by 3. 21 divided by 3 I know to be 7. 57 divided by 3 is going to end up being 19. Now I know 7 is a prime number, so only 1 and 7 go into both to 7. 7 does not go evenly into 19, so 7/19 is going to be my fraction in simplest form. There may be times where I have to take this fraction that I create first and have to divide and look for another number. I always want to check to make sure there's the only numbers that go in evenly into both are going to be 1. It's important for us when working with fractions to know what an improper fraction and a mixed number is. An improper fraction simply means a fraction whose numerator is bigger than its denominator. So improper fraction examples can include any fraction. The only thing that has to be true is once I have a numerator, say 24, my denominator has to be smaller than that. So it could be 9, it could be 24 tenths, it could be 24 23rds. We could name an endless amount. Any fraction that has a numerator of 24 would be considered improper if its denominator was smaller than 24. So we could do something like 57. All our possibilities for fractions then, our denominator would have to be smaller than that. So we could do something like 13, we could do something like 3, we could do anything up to the number 56. When we're looking at mixed numbers, a mixed number is a number that includes both a fraction and a whole number part. So if we have the whole number 3 next to the fraction 1/5, that would be a mixed number. The word mixed comes from the fact that we have both of those parts included. We could have 4 and 2/9. We could have 18 and 26/31, or any combination of a fraction and a whole number. Oftentimes when we work with fractions, we're going to get an answer that looks like an improper fraction. As the word improper suggests, we don't want to leave our fractions as improper. We always want to make them mixed numbers. So we're going to take a look at how to do that. We're going to start by dividing the numerator by the denominator and putting the remainder over the denominator. And we're going to simplify if necessary. So taking a look at 54 over 8, I'm going to see how many times does 8 go into 54. So I'm thinking about my math facts. I know that 8 times 6 is going to be 48. So 8 times 6 is 48. So my whole number becomes that 6, that whole number. So I divided the numerator into the denominator. My remainder is going to go over the denominator. So my denominator of 8 stays the same and becomes the denominator of my mixed number. Now I know 6 times 8 is 48. My remainder is going to come from finding the difference between the numerator I had there, 54, and whatever the whole number times the denominator was, so 48, so I'm going to have 6 there, and so I'll have 6 and 6/8. Now what I have to remember is that last step, simplify if necessary. Since 6/8 can be simplified, I'm not going to leave my mixed number like that, but I'm going to divide my numerator by 2 to get 3, and my denominator by 2 to get 4, and 6 3/4 is going to be my final answer. For 36 divided by 7, I'm going to see how many times 7 goes into 36. Evenly. I know 7 times 5 is 35. And I know my denominator is going to stay the same as 7. So I need to find that difference between 36 and then whatever 7 times 5 is, which I identified as 35. So I'm finding that difference to be 1. So my mixed number is going to be 5 and 1/7. Now I know 1/7 can't be simplified any farther since 1 is the only number that can go into 1. So 5 and 1/7 is going to be my final answer. Even though we never want to leave our answer as an improper fraction, it's still going to be important for us to know how to convert from mixed numbers to improper fractions, as it may be helpful for us while we're adding, subtracting, multiplying, or dividing fractions to use the improper fractions rather than the mixed numbers. So in order to complete this task, we're going to multiply the denominator by the whole number and then add the numerator. So sometimes when we see a mixed number like 3 and 5, 6, we might write in the symbols multiplication there and add at the top. Then we put the resulting number over the original denominator to produce the improper fraction. So what it tells me to start off with is multiplying the whole number 3 by the denominator, which is 6, so I get 18, and then I need to add the numerator. So 18 plus 5 is going to be 23. This becomes my new numerator, and my denominator stays the same as it was, my 6 at the bottom. Again, I can check my work here by using the steps I did for converting an improper fraction to a mixed number. 6 goes into 23 3 times. That would be 18. So I need to find that difference. 23 minus 18 is going to be 5. So I'd have 5, 6. Notice these two mixed numbers match, so I know that I did a good job of doing my conversion. With 5 and 4/7, again, I'm going to multiply 5 times 7, which is 35. I'm going to add 4, that becomes 39, which is my new numerator. And then 7 is going to stay the same. Again, I can check just by seeing that 7 goes into 39 5 times. 7 times 5 is 35. So 39 minus 35 is going to be 4. So I have 4, and my denominator never changes. Notice in both conversions, my denominator is never going to change. At this point, you can go ahead and complete the rest of your video answering questions about simplifying fractions, finding equivalent fractions, and doing conversions between mixed numbers and improper fractions and vice versa.